Okay, open your notebook. You're going to go to page 7, and the title is Solving and Graphing Inequalities. An inequality is just like an equation with one difference. An equation uses an equal sign, but an inequality uses a greater than or less than symbol. So here's an example. This looks almost just like the problems that we did last week. The only difference, like I said, is that instead of an equal sign here in the middle, we have this inequality symbol. We're still going to follow the same steps that we did last week. I'm going to start off by drawing a line coming down from my inequality symbol. So instead of an equal sign, I just have my inequality. When I see parentheses, I'm going to do that first, and I'm going to distribute. So over here I see some parentheses. So I'm going to distribute the -8, and then I'm going to rewrite the problem. So now I have 4 minus 2m, my symbol. -8 times 4m is -32m. -8 times 7 is minus or -56. I showed you a strategy last week using highlighters, so I'm going to do that again. I'm going to highlight the constant terms in yellow and the variables in green. So you can see that we have yellow and green on both sides. Remember that we need all of the green to be on one side, all of the yellow to be on the other side. So variables on one side, constants on the other. I am going to move this -32m. The opposite of -32 would be positive, so I'm going to add 32m to both sides. Remember, I do that in red. Draw my line. All right, so I have 4. -2m plus 32m is a positive 30m. -32m, positive 32m, those will make a zero pair. They cancel each other out. Bring down my -56. Then I'm going to highlight again. The constants in yellow and the variable term in green. So now I have yellow on both sides, so I need to move the 4 to get it away from the m. It's positive, so I subtract on both sides. Positive 4 and -4 cancel out. That's a zero pair. I have a positive 30m. Over here, -56 and -4 combines to a -60. Now I'll just divide both sides by 30. Down a little bit. All right, so 30 divided by 30 is 1, so I just have m. Over here, -60 divided by 30 is -2. And remember, this is not an equal sign in the middle. It's an inequality, greater than or equal to. So I'm going to slide that down. Greater than or equal to. Here's my answer. We talked about with equations how you can turn the answer around and write it the other way with the variable first or with the number first. You can do that with this, but you need to be careful. If you're going to try to turn this answer around to put the to put the number first instead of the variable, we're going to put -2. and then that'll be on the left, and of course the m would go on the right. But pay attention to that inequality symbol. This inequality is open facing the m, and it is pointing at the -2. If you're going to turn this around, you have to turn around the whole thing, including the inequality symbol. So m is greater than or equal to -2, but if you start with -2, it's less than or equal to m. One more thing that makes an inequality different from an equation is the way that we can graph the solution. So I can represent the answers to this on a number line. So I'm going to draw a number line. You do not have to put 0 in the middle. I'm just going to put some numbers. I'm actually going to put -2 in the middle because that's my reference value, if you will. That's the number that I'm using. And then I'll put a couple of numbers in each direction. So -2 to the right would be -1, 0, +1. And then to the left, I'll put a couple of numbers here. Counting backwards would be -3, -4, -5. Graphing an inequality involves two parts, a circle and then an arrow. The circle indicates whether or not that number is actually part of the solution. Since this says m is greater than or equal to -2, then that means that -2 is part of my solution. That means I draw a closed or colored in circle on the -2 on the number line. If the -2 didn't have the little equal to sign here, then the -2 is not actually part of the solution. If it was just greater than, then you can get close to -2, but you can't actually touch -2. It's not part of the answer. Now, -2 is not the only number that makes this true. There are more numbers because m is greater than or equal to -2. So using this value, -2 makes it equal. But what values would make it greater than -2? Is -3 greater than -2? No. Is -4 greater than or equal to -2? No. So the numbers this way are not part of the solution. Let's check the other side. -1. Is -1 greater than or equal to -2? Yes, -1 is greater than -2. All right, what about 0? Is 0 greater than -2? Yes, and so is 1 and 2 and 3 and 4 all the way to positive infinity. So every number on the right-hand side of the number line makes that a true statement. So I am going to draw an arrow. I'm going to kind of shade the number line in. The arrow says that every number in this direction, because we can't just draw little dots, dot, point, 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 dot, dot, everywhere. So instead of doing that, we just draw an arrow. So we draw an arrow in the direction of the answer. All right, let's do another one. $35 plus 7p is less than -5 parentheses 1 minus 3p. All right, now you can pause the video and see if you can work this out by yourself. Follow the same steps as with an equation. Remember to distribute and then isolate your variable and divide. Okay, I'm going to start off by drawing a line from my symbol. Because of the parentheses, I need to distribute, so I'm going to do that first. So this side stays the same, 35 plus 7p. Negative 5 times 1 is negative 5. Negative 5 times negative 3p is positive 15p. After I distribute, I highlight my like terms. Okay. I am going to move my variables. I'm going to bring it over here to the left, so I'm going to subtract 15p because it was a positive, so I'm subtracting. To do the opposite, I have 35 minus 8p and then negative 5. I'm going to highlight again, like terms. There's the constant terms. And here's my variable. So can't have yellow on two different sides. I need to bring those together. Away from the green, away from the variable. So I'm going to now subtract 35 because it was positive. And I have negative 8p. Negative 5 minus 35 is negative 40. Last, I'm going to divide, and I'm dividing by negative 8. All right, so now I have p. Over here, negative 40 divided by negative 8 is a positive 5. Now, here's another thing that's different. If you pay attention, close attention, to the number that we divided by, when you divide by a negative value, you have to flip your inequality symbol. We divided by negative 8. On the last problem, we divided into negative 60, but when we divided by, or what we divided by, was positive 30. Here we are dividing by a negative number. When you divide by a negative, you take the inequality. Instead of a less than, it is going to flip and become greater than. Then I'm going to graph that on a number line. I put my positive 5 in the center, 6, 7, and then 4, 3. Put a couple numbers on each side. This is a greater than symbol, not a greater than or equal to. So that means that my solutions are close to 5, but they can't actually touch 5. Since it doesn't say p is greater than or equal, p cannot be equal to 5. P has to be greater than, which means the number 5 itself is not part of the solution. So now we check the other values on the number line. 4. Is 4 greater than 5? No. Is 3? Is 3 greater than 5? No. That means that all the numbers to the left are not part of the solution. Let's look on the other side. 6. Is 6 greater than 5? Yes. 7. Is 7 greater than 5? Yes, it is. So all of the numbers to the right are part of the solution, and I'm going to draw the arrow going to the right. Okay.